Operations with fractions. Alright, so what are operations with fractions? Basically that's just a fancy way of saying we're going to multiply fractions, divide fractions, add fractions, and also subtract fractions, okay? So let's not waste any time, let's just dive right into the problem solving. So we're going to start with multiplication here. So we got 2 divided by 5 times 7 divided by 4, okay? Now, when you're multiplying fractions, you can just multiply straight across, okay? You just multiply the top numbers and you multiply the bottom numbers. But there is a trick that, when it's applicable, makes this much easier to do. So what you can do is you can call it cross-reducing. So you look at the diagonals here, okay? And you say, is there any number that can go into this number and this number evenly, okay? Well, in this case, the 2 can be divided by 2 once, and the 2 can go into 4 twice. So we just cross-reduce that guy. Now, 5 and 7, there's no number that can divide evenly into both of those guys, so you leave them. So what are you left with? Well, you just have 1 over 5 times 7 over 2. Now you just multiply directly across. So 1 times 7 is 7, and 5 times 2 is 10. Okay? Okay, not too bad, right? So let's try one more. Multiplying fractions. Okay, this time we got 2 and 1/3 times 6 over 5. Now, what's different about this guy than the last problem? Okay, this guy we got do you remember what this is called? From the last video? It's called a mixed number, okay? So the first thing you got to do is you have to change this mixed number into an improper fraction before you multiply. So do you remember how we do that? We multiply those numbers and then we add it to the top, okay? So 2 times 3 is 6, 6 plus 1 is 7, and you always just keep the bottom here. Okay? Now, before you just go multiplying these guys across, always check the diagonals, okay? You want to check here and here. The 7 and the 5, nothing can reduce into those, but what about the 3 and the 6? Is there any number that can go evenly into a 3 and a 6? Give me a second to think about that. Well, a 3 can go into 3 one time, and a 3 can go into 6 2 times. So now the numbers are a little bit smaller to work with, so a little bit easier to multiply. So 7 times 2 is 14, and you divide that guy by 1 times 5, which is 5. Now, this is an improper fraction because the top number is bigger than the bottom number. So we don't typically want to leave it like that. So if you recall from the last video, you can change this by saying, how many times does 5 go into 14? You know, how many times can you take a 5 out of 14? Well, 5, 10, 15. 15 is too much, so you go back 1. So 5 goes into 14 2 times, and then you say what's left over. Well, 14 minus that 10 is just 4 over, you always keep the same bottom. So your final answer is 2 and 4/5. Okay? And that's how you multiply fractions. Alright, so after multiplication, it is division. So we got 15 divided by 21 divided by 5 over 7. Now, you're going to like these guys, because if you understand multiplication, you're going to understand division. Because what you do is you just take this back guy here, and you just flip it upside down. Okay, so that's your first step. So you got 15 over 21, and then you flip this guy upside down. It's called reciprocating. So you're going to do the reciprocal of 5 over 7, which is 7 over 5. And instead of a division, you just make it times. There we go. We're multiplying again. Okay? So, again, you just flip that back guy, pop it there, and put a multiplication symbol, okay? Alright, so check it out. Again, always check your diagonals first, because it can make multiplying a lot simpler. That being said, this one's nice because 5 goes into 5 once, and 5 goes into 15 3 times, and 7 goes into 7 once, and 7 goes into 21 3 times as well. Okay? So, you just start multiplying those reduced numbers. 3 times 1 is 3. 3 times 1 on the bottom is also 3. Now, we have the same number divided by the same exact number. Whenever that happens, it's pretty cool because the answer just becomes 1. Okay? So 15 divided by 21 divided by 5 over 7 equals 1. Pretty cool, right? Alright, let's try another one of these guys. So, again, you know we gotta throw some mixed numbers into there. So we got 4 and 7/8 divided by, let's see, 13 over 8. Okay, so again, first step, if you have a mixed number in here, always change that guy to an improper fraction before you start multiplying and dividing, right? So again, multiply those, add the top. 4 times 8 is 32, plus the 7 on top is going to be 39, and it's always divided by the same guy that's on the bottom here. Now again, remember, you're going to make this multiplication, and you're just going to flip this guy, okay? You're going to flip the second guy. So instead of 13 over 8, you have 8 over 13. Now, check the diagonals, okay? This one's nice because, okay, 8 goes into 8 once, 8 goes into 8 once. Now, these guys, the 39 and the 13. Is there any number that can go evenly into a 13 and a 29? Okay? Well, 13 goes into 13 once, and 13 goes into 39 3 times. Okay? So it reduced very nice. And you see why this cross multiplication thing is so important, because instead of doing 39 times 8, which is going to be a pretty big number, you're just doing 3 times 1. So it's much simpler. So 3 times 1 is 3, divided by 1 times 1 is 1. Now, whenever you just have a number divided by 1, it's always just that number. So 3 over 1 is just 3. And that's dividing fractions, okay? Not as scary as you thought, right? Alright, so after division, we've done multiplication, we've done some division, now we gotta add, okay? And there's a couple, different rules with adding that we'll go over right now, okay? The first rule of adding is the same thing with subtraction, by the way. We're doing subtraction next. I'll just give you a little bit of a head start. The bottoms always have to match. The bottoms have to match when you're adding and subtracting. In this case, they already do. So when that happens, when the bottoms match, you just add the top numbers. 4 plus 6 is 10 divided by, you just carry that number over. Since they're the same, you just put that guy there, okay? And then you always gotta look at your answer and see if you can reduce it. Can you reduce that by anything? Well, 5 goes into 5 one time, 5 goes into 10 two times. You're left with 2 over 1, which we know is just 2. In other words, 5 goes into 10 two times, okay? And that's that. Now, let's do a subtraction one like that, and then we're going to move on to some a tiny bit harder stuff, okay? So we got 7 over 4 minus 3 over 4. Again, bottoms have to match, okay? The bottom is called the denominator of a fraction. The top is called a numerator, okay? So if I ever say denominator, I'm talking about the bottom number. So here the denominators have to match, which in this case they do. They're both 4. So you can just subtract the top. 7 minus 3 is, well, 7, 6, 5, 4. And then again, you just keep the bottom number. 4 over 4, remember what happens? Remember what we do when that happens? If you have the same number on top divided by the same exact number on bottom, it's just equal to 1. Okay? Now, let's do some adding and subtracting that's a little bit more involved. So we got 5 divided by 6 plus 2 divided by 3. Now, can we just add the tops like we did before? No, right? Why not? Because the bottoms do not match. So we got to do some magic here to make a match. So what you have to ask yourself is you have to say, how can I make both of those numbers the same? All right? In other words, what can I multiply to this 3 that will give me 6? Well, if you multiplied it by 2, the bottoms would match. Now the only caveat to this is if you multiply by 2 on the bottom, you have to multiply by 2 on the top. Okay? So, now you have 5 over 6 still, this fraction here, plus now you got 2 times 2 is 4, divided by 3 times 2 is 6. Okay? Now the bottoms match, so you can add the tops. 5 plus 4 is 9, divided by, again, you just take that number, and now you just reduce it. So you say again, what number can go into a 6 and a 9 evenly? Another way to do this was what you learned in the last video, was to do the prime factorization tree. So I guess I should just stick to that method. So this is going to be 3 times 3, 6 is 3 times 2, okay? So we end up with 3 times 3 on top, and the prime factorization of 6 was 3 times 2. There's a 3 on top, 3 on bottom, they cancel out. You end up with an answer that is 3 divided by 2, okay? Let's try another one. And at first, these they can seem a little tricky, but I assure you, if you practice just a couple of them, if you do them alongside me, again, I'm gonna reiterate this all the time. You should be taking notes, okay? That being said, follow along with me. Try to do the problems before I do them, and you'll understand them. So our next one, 3 over 7 minus 2 divided by 4, okay? Now, again, these do not match, so you have to do something to them first. So you have to say, okay, what's the smallest number that the 4 and 7 both go into, okay? So that's what you're trying to ask yourself. The question is, what number can 4 and 7 go into, okay? And in this case, the answer is going to be 28, okay? So 28, I'll just kind of write it over here, okay? And how we got that is we just kind of multiplied both those together. The reason it's 28 is because 4 can divide into 28. 7 can also go into 28. Another way to think about this is you have 7. You should basically keep adding 7. So you have 7, 14, 21, 28, and they can keep going, okay? With 4, you got 4. We're just counting by 4s now. Here we counted by 7s. Now we're counting by 4s. 4, 8, 12, 16, 20, 24, and 28. That being said, the smallest number that both of these numbers, 7 and 4, fit into is 28, okay? So hopefully that makes a little bit of sense. So, we know that we need the bottom to be 28. So how do we do that? Well, you have to say, what can you multiply to the 7 to make it a 28? Well, you can multiply it by 4, and you can multiply the top by 4. I mean, if you multiply the bottom by a number, you have to multiply the top by that number as well. So again, we want 28. 4 times what gives us 28? 4 times 7. You do it to the bottom, you've got to do it to the top, okay? So you just start, doing the algebra here. So 4 times 3 is 12, divided by 4 times 7, which we know has to be 28, minus 2 times 7 is 14, divided by 28. Boom! The bottoms now match magic, right? That's what we wanted. Now you can just subtract them right over. So, what's 12 minus 14? Now this is one of those kind of tricky ones. When you're adding or subtracting, I always relate it to money. So you have $12 in the bank. You buy something for $14 because it's a negative. Negative is like you purchase something or it's debt. Well, how much do you have in the bank now? Your bank account would read negative $2 over 28. Again, we just keep the bottom. Now, you ask yourself one final question. Can this fraction reduce? What do you think? Can negative 2 over 28 reduce? Well, you always want to ask yourself one question. Is there a number that can go into 2 and to 28 evenly? In this case, 2 goes into 2 once, 2 goes into 28 14 times. So yes, it could reduce. And you're left with negative 1 divided by 14. And that is your answer. Now, one common mistake is always bring down the negative. It doesn't just disappear. Sometimes students will forget to write it. I would suggest always take your time, okay? Math is not a race. We like to try to get our math done quick, get it done now, because we don't tend to really enjoy math so much. So just slow down, you'll make a lot less mistakes, and you'll understand it a little bit better, which will inherently cause you to enjoy math a little bit more. So that is operations with fractions.